Today we're going to cover topic 8.10, surfaces of revolution around other lines. So in other words, we're rotating, when we say other lines, we're talking about something besides an axis. All right? So let's look at this first problem. We have an area bounded by the x-axis. X equals pi halves, and y equals sine of x. But this time it is revolved around pi halves, which is right here. So this shaded area is being rotated this way. So this in here is my radius. And that radius is going to be this whole distance, which is pi halves. So my radius is going to be pi halves minus, get a different color here, minus this function value, minus f of x. All right? So we have to do subtraction to get my radius on this problem. All right? So my function, unfortunately, is solved for y. So I have y equals sine of x. I need to solve it for x, which means taking the arc sine of both sides. The arc sine of y equals the arc sine of the sine of x. That's how I take care of that. And so I have that x equals the arc sine of y. So when I talk about this function right here, this is my function. All right? So my integral, it's the same setup as when we're doing, other problems involving a washer or so on. Not a washer, but a disk method or so on. I'm still going to have the radius squared. So my radius is this. It's going to be pi halves minus the arc sine of y. That quantity is going to be squared. I'm going to have a pi out in front of it. All right. And that's going to be a dy. Now, what are my limits of integration? I need to use y limits. All right? So because I'm going to pi halves, it's 0 to 1. All right? And so remember, anytime we're doing it with respect to y, we need to use y limits. And so that's a pretty straightforward setup. This would probably definitely be a calculator type problem. Put it into Math 9, and we get 3.586. All right. Now let's look at this next problem. The area bounded by y equals x squared plus 4x plus 4. So let's make a note about that. That is x plus 2 quantity squared. All right, which means that that has one intercept at x equals -2. So when I sketch this thing, it is a parabola where the vertex is touching right here at -2. All right. And this y-intercept, so I'm bounded by y equals 4, which is here. But I'm also revolving it around y equals 4. So this shaded region in here, this is being rotated around the line y equals 4 to get my solid. All right? So my radius is this distance right in here. That's my radius. So once again, we have to do subtraction to get the radius. This one's a little bit easier, I think, than the last one. The radius is 4 minus the function. We have to subtract out the function value to get this radius. So my radius is 4 minus that x squared plus 4x plus 4. So we can clean that up a little bit. We may as well before we put it in the integral. That's going to be 4 minus x squared minus 4x minus 4. So my radius is just negative x squared minus 4x. So my integral on this problem is going to have pi out in front of it. Then I'm going to have negative x squared minus 4x is going to be squared dx. My limits of integration are x values this time. All right? So I need to think, I need to think about this one right here. What is this x value? Well, you'd have to go someplace and set x squared plus 4x plus 4 equal to 4 to get your limits of integration. So the 4's go away. You have x squared plus 4x equals 0. Factor out an x. You have x times x plus 4. So your two coordinates are going to be 0 and negative 4. So we're going to go from negative 4 to 0 on that. This is definitely a problem that could be done either analytically without calculator or with calculator. I will caution you about squaring this. All right, remember, you do not just distribute this power. You've got to treat it like you are multiplying negative x squared minus 4x times negative x squared minus 4x. All right, so be cautious with your algebra if you're doing that one analytically. If you were actually doing this analytically, you would have x to the 4th. Then you would have plus 8x cubed plus 16x squared. And that's what you would integrate from negative 4 to 0 and multiply it by pi. Your final answer on this problem, calculator or no calculator, is about 107.233. Of course, you'd have to find a successful antiderivative and so on. The big thing on these problems is the setup. And that should help you on topic 8.10. We will stop there for today.